exact equations with integrating factors. So this is for exact equations that, ordinary difference equations that aren't exact, but you can multiply by something to make them into an exact equation. So, right, for that to happen, let's say we have a Mars of x comma y plus Neptune of x comma y times y prime equals 0, and right, the partial derivatives of don't match, right? So partial Mars, partial y does not equal partial Neptune, partial x. The equation is not exact. All right, so, but what if there was a way, and here's the idea, is we multiply by an integrating factor. We'll call it mu of x comma y. Sometimes it's only a function of x, sometimes it's only a function of y, sometimes it's a function of x and y. But the idea is multiply by mu of x comma y to make the equation exact. Make the ODE exact. All right, so then your new equation would be mu of x comma y times Mars of x comma y plus mu of x comma y times Neptune of x comma y prime equals 0. And then somehow the partial derivative with respect to y of now this whole piece here, it's kind of like I lumped in something else with the Mars of x comma y. So mu of x comma y times Mars of x comma y does equal partial x of mu of x comma y times Neptune of x comma y. If that's true, then the equation is exact, and then you can solve it as an exact equation. So here's a really quick example of an equation and an integrating factor. So let's say we have 3y plus y squared over x plus y prime is equal to 0. All right, so our m, our Mars, is this 3y plus y squared over x, and our Neptune of xy is this x plus y. All right, so let's go ahead and take a look and see if this is exact. So we've got partial Mars, partial y. Well, that equals, okay, take the derivative with respect to y here, so the 3y turns into 3, and then the y squared over x turns into plus 2y over x. All right, and the partial Neptune, partial x, that's equal to, looks like 1 plus 0. And those definitely aren't equal. All right, so this equation is not exact. So then what if instead I use this mu? This one is, I'll put both, so y equals x squared. All right, so now let's multiply the entire equation by x squared, so I'll end up with 3x squared y. 3x squared y plus, I've got y squared over x times x squared, so that will end up being xy squared. Plus, all right, I've got x times x squared, so that's x cubed. And then y times x squared, so that's plus x squared y. Y prime equals 0, right? 0 times anything is still 0. So now let's take a look. So this is the new m, Mars of x comma y. And this is the new Neptune of x comma y. So we have partial Mars, partial y. Okay, well, let's see, a little more complicated. We get 3x squared times 1, so 3x squared. The next piece, we get xy squared, so that's 2 comes down, we get 2xy. And now we have partial Neptune, partial x. Well, that's, sorry. So I take the partial derivative of x cubed plus x squared y. So x cubed will turn into 3x squared. Things are looking good. And the x squared y will turn into 2xy. And yeah, they do agree. So the equation is exact and can be solved. The equation, the ODE is exact now. All right, so now the question is, how does anyone come up with the integrating factor? And so we'll do that in the next video, and there's generally 2 ways to get it and then there's some things you can try sometimes.